Hello everyone, welcome to Helper. In this video, we will learn about Thevenin Theorem and solve some numerical problems related to this topic. So first of all, we will understand the Thevenin Theorem. What is Thevenin Theorem? And then we will solve the numerical questions. So the Thevenin Theorem states that the current passing through a load resistance, suppose the load resistance is RL, is connected across two terminals, that is A and B, of a linear active bilateral network system. At that case, the current would be VTH by RTH plus RL. Here the VTH means the Thevenin voltage, or you can say it as open circuit voltage VOC, by RTH. Here RTH means Thevenin resistance and RL means the load resistance across which the current has to be measured. Now you can see here RTH means the Thevenin resistance as viewed back into the open circuit network from terminal A and B, with all voltage source replaced by their internal resistance and current source by their infinite resistance. Here infinite resistance means the current source would become open circuit. Okay, we will talk about this later. Now simply we can say that Thevenin theorem is a process by which we can convert any kind of complex bilateral active network system into a equivalent circuit where only one voltage source is present along with the resistance, that is RTH, in series combination across the two terminal. Okay, so this is the most important point, that is we can convert any kind of complex bilateral network system into a simple circuit with a voltage source connected across with a resistance in series combination across the two terminal. Here the terminal is A and B and RL means the load resistance. Okay, now we will solve this numerical problem to understand this Thevenin theorem much more deeply. So this is the question, and in this question we have to find the current through this resistance, 15 ohm resistance. Okay, so now this is the load resistance and we have denoted these two terminal A and B, and we have to find current in this branch. Okay, so first step that we have to do is, you can see this is the step number 1. We have to remove the load resistance which current is to be measured. Okay, this is the step number 1. In step number 1 we have to remove the load resistance. Okay, now we have removed the load resistance. Now the circuit look like this. And in step number 2 we have to draw circuit to find VTH or VOC. In this case no source would be replaced either by short circuit or by open circuit. Okay, so this is the circuit for suppose VTH. Okay, now we have to find VTH. Okay, so now for VTH, look, in this circuit this 12 ohm resistance is directly connected with these two terminal, so we can simply say that the voltage across this 12 ohm resistance is the open circuit voltage across these two terminal. Okay, so if somehow we find the voltage across this 12 ohm resistance, then we can say that this voltage would be the terminal voltage across this AB, that means the VTH. Okay, look, this is the voltage source having internal resistance 1 ohm, and 3 ohm resistance is connected in series, and also this 12 ohm resistance connected in series. Okay,
In this case, we will not consider this A and B terminal, okay? We can neglect this A and B terminal and calculate the voltage.
now we will apply voltage divider rule. Okay, so using voltage divider rule, we can say that voltage across this 12 ohm resistance is, the resistance is 12, so it would be in numerator, then the total resistance, that is 1 plus 3 plus 12 into the voltage source, that is 24. It would be 12 by 16 into 24, so it would be 18 volt. So this is the voltage across this 12 ohm resistance. Okay, so it would be our VTH. Okay, in step 3 we have to draw the circuit to find RTH. We have to keep in mind this, in this case source would be replaced. Okay, source would be replaced either by internal resistance, short circuit, or open circuit. Here voltage source would be changed in short circuit and current source would be changed in open circuit. So this is the circuit for finding RTH. Look, in this circuit, this 12 ohm resistance is connected parallel with these two resistors. If we convert this into a simple form, the circuit would be look like this. This is the two terminals A and B, and this is the 12 ohm resistance, and this 3 and 1 is series. Okay, so this is the simple form of the circuit. So 3 and 1 means 4 and 12. So this 4 and 12 is in parallel combinations. So the equivalent resistance is 4 into 12 by 4 plus 12, that is RTH. So 4 into 12 is 48 divided by 16, and it's equals to 3. So 3 ohm is RTH, and we have already find VTH. Now in next step, that is step number 4, we will draw the Thevenin equivalent circuit and find the current using this formula. So this is our Thevenin equivalent circuit, and this is the load resistance. So now we will find the current. Okay, that is I. I is equals to VTH by RTH plus RL. Here VTH is equals to 18 volt, RTH is 3 volt, and RL is 15. So 18 by 18, that would be 1 ampere. So this is our answer. In next video we will solve few more questions on this topic. Then we will learn about Norton's theorem. Till then, take care, and please don't forget to subscribe our channel.